All right, what we're going to do is we're going to do a little demonstration here, Multisim, and we're going to run this here, and we will find our Multisim. We go over to National Instruments, scroll through here. We open up our National Instruments, and then what we're looking for is our Multisim 14.0. I've got mine open already, so I'm just going to pop open my screen. Now, as we do this demo here, what we're going to do is we're going to actually build a circuit that is in activity 1.15b circuit theory. And I'm going to do problem number 2. And problem number 2, in that one, we're going to use our meters and set up our meters and show you how to bring out components and everything. The method I like to use, you can select, they have a bunch of little icons up here. You can pull your parts and everything from these icons. I like to use the method by going to place, components, and then what I want to do is I go to basic here in the groups, and I should be able to find my resistors right there. And when it comes up, I got this 1K resistor here. I'm just going to say OK. I'm going to place that 1K resistor out there, even though that's not the resistor I'm using. I should have a 470 and 1.2K ohm from problem number 2, and then a 270 ohm. So now I'm going to put out a second resistor right there, and I need to put out one more resistor right down here. So I've got my 3 resistors out. Now I want to change. I'm going to say OK here, and I'm going to hit escape, get rid of that extra one there. Close this out. Now what I'm going to do is I'm going to open this one up, and I'm going to change this guy. This one's going to be the 470. Say OK. Going to double left click on this one. And this is going to be the 1.2K. And then my last one on the bottom, I'm going to double click on it. And I'm going to make that the 270 ohm. All right, now, next thing I need is that battery, that power source. So I'm going to go place, components. What it is, it's under sources and power sources right there under family, and it's a DC, direct current power source. There's our symbol for our battery. Say OK, place my battery right there. Another thing I'm going to need is we need a ground, and I'm going to use this ground right here, analog ground. I'm going to place it right down there. And that's one thing that Multisim requires and needs to operate. If you don't put this ground here and hook it to the minus side of the battery, then you're going to have some trouble. All right, next we're going to hook some wires up. What we can do is we just go right here to the plus side of the battery and go left click, and then go up, left click, make my corner, left click right there on the resistor to make a connection. Move my mouse over here till I get this little plus sign with a dot, left click, move it over to there, left click. Then I'm going to click on this side, then left click to make a little corner, come down to approximately there, left click and anchor, left click, left click, left click, hook up to the minus side. Like I said, I'm going to hook this up. I could have hooked it right there, it doesn't matter, just as long as it's on the minus side of the battery. Right there. All right, I got my circuit all hooked up. So one of the things we want to do in the activity is the activity wants you to find the total current and the voltage across the resistors. So what I'm going to do is I'm going to bring a meter out, and this is a little digital multimeter. If you move your mouse up here, just kind of hover over these instruments, you can see the different names of the instruments. And the first one we want right there is a multimeter. I just left click, let go, slide this out here, and I can put that meter right there. I can even bring another meter out, second one. And then I'm going to bring a third one out. Whoops. And connect it right there. Now, one thing you want to do is, if you want to make sure polarity is proper, you always take the plus side of the meter and connect it back towards the plus side of the battery. Take the minus side and hook it to the minus side of the, going towards the minus side of the battery on that component. So we just bring these down, hook our meters up, here I got to do a little swap. All right, got my meters hooked up. Now, if I double click on the meter, I get a meter that pops up on the screen here. So that's that guy, XMM1, XMM2, and XMM3. Now, there are selections on here, just like a regular meter. There's selections. There's a lot less on these. But what we want to do is we're measuring DC. This is direct current. So we got to have that one selected. That one's selected there. It's usually selected on the meter. And the other thing we're doing is measuring voltage. So we got the V here. We don't want the amps. We don't want to do resistance. So we're going to do volts. And volts has been selected on both these. So now we're ready. We can start our simulation. Ooh, I got one thing I almost missed. And that's one thing that happens with the students on this activity is the power supply changes. So we're going to change we're going to double click on our power supply right here, double left click. And we're going to change that. It's a 9 volt in problem number 2. So the students have to be careful of that. Sometimes I miss it. You know, students say, how come I got a different reading? Well, they didn't put all the right components in. So we got a 470, 1.2K, and a 270 ohm resistor. And now we go up here. There's a little green arrow here called the run arrow. So we're going to click on that. And we start our simulation and our meters start reading. So there's our voltage readings across all these devices here. And you do that with a voltmeter. Voltmeters can be used with power on, and they are placed across the device that you want to measure the voltage on. So this would be a good setup for reading voltage. Next, let's do current. And current's a little trickier. I'm going to shut off the simulation. In order to do any changes, you got to shut off simulation. I'm going to go up to this little red block. It says stop. Left click on it. And I'm going to delete that meter, delete that one, delete that one. Actually, I'm going to highlight and delete these. I can left click on it, then right click and go up here to delete. Left click, right click, and delete. This I'm only going to delete the leads. All right, now next we want to read current. Now this is a series circuit, so whatever current's coming out of the battery is the current that goes through each one of the components. The only way to do that is we got to read properly. We've got to put the amp meter in series with the circuit. So we got to destroy the circuit, kind of. I tell the students we got to remove a wire. So I'm going to delete this wire right there. And I'm going to hook the plus side of my amp meter to there, and there, and there, and there. And as Mike explained in the video, if you set up your meter for reading amps and you hook it across the resistor like a voltmeter in parallel with it, you're going to blow the fuse inside of it. So the other thing is, before we go up here and start our simulation, basically starts the power up, let's open up our meter, select current, set for DC. Now if we hit the run button, there we go, 4.639 milliamps. So that's how we read current in the circuit. Now I got one more thing I want to show. I want to show how to read resistance. And with resistance, when you're using a digital multimeter to read resistance, you need an ohm meter. So what we're going to do is I'm going to disconnect this right here. Yeah, I stopped the simulation. That's good. So I'm going to, you can hit the delete key, highlight these and hit the delete key. And I'm going to move my ohm meter right down here. And the battery is basically disconnected. We could delete this little wire right here if we wanted to, we could. But the battery is basically disconnected from the circuit. And the ohm meter doesn't have polarity. Basically, you don't have to worry about polarity when you're doing this. So all I'm going to do is I'm going to hook, battery is out of the circuit. You can't have power to a circuit when you're using an ohm meter. So now I'm going to wire this down here. And what I'm going to do is I want to get the total resistance of this circuit right here. Open this up, select ohms, go up here to our simulation, and there we go, 1.94K ohms. 1.94K ohms. That looks about right. So, but anyway, that's how we use our multisim. That's how we build these circuits here. That's how we insert the meters. Especially when you're doing total resistance here, you want to disconnect the power supply. Don't forget to change your battery voltage on these, and make sure all your resistors are the same. So parallel circuits are not that much different. So, all right, thank you for watching, and hopefully you'll have a successful activity here with 115A through 115C.